Hello friends, today I'm going to solve LeetCode problem number 2359, find closest node to given two nodes. So in this problem we are given a directed graph with n number of nodes. Each node is labeled from 0 to n minus 1, and we are also given an edges array where each value in the edges array represents a node from that index to the value at that index. And if the value of that index is -1, that represents that the index I has no outgoing edge. For example, here the index 3 here, the value of index 3 here is equals to -1, right, which represents that index 3 has no outgoing edge. Now we are also given two nodes, node 1 and node 2, and we need to find the we need to find if we could reach a node from node 1 and node 2 such that the maximum distance between node 1 and that node and from node 2 to that node is minimized. So what does that actually mean? Let's see here in this example. So this is the first example in our LeetCode problem. So what's the node 1? Node 1 is 0 and node 2 is 1, right? So we are basically starting from 0. So where does 0 where is 0 directed to? Well, it's directed towards node 2, right? So 0 is towards node 2, and then what about 2? Where is 2? Since this is at index 0, this is at index 1, 2 and 3. So node 2 is directed to node 3, right? So node 2 is directed to node 3 in this graph. And what about node 3? Node 3 has no outgoing node here. So now we move to our next node, which is node 2, which has a value 1. So at index 1 we look at the value for in the edges array, and the value is equals to 2, which means that node 1 is directed towards node 2. Now what about node 2? We have it already, right? So now that we have formed our graph, we need to find like which is the common node that we could reach from both node 1 and node 2. And if it's common, if we can reach, we need to find the minimum distance, we need to like minimize the maximum distance between well, basically the maximum of the distance maximum of this distance and this distance should be minimum. So let's see, for example, from node 1 we can reach node 2 and node 3, and we can also reach node 2 and node 3 from node 2 as well, right? So now what's the distance? The maximum of the distance to reach node 2 from 0 is equals to 1, and same from node 1 to 2, right? What about 3? Well, the distance is equals to 2, but we are gonna use the one with the minimum distance, so this one. So node 2. Now let's look at this example here. So our node 1 is at index 0 and our node 2 is at index 2. Since node 0, we start from node 0, and then what we see is we could go to node 1, right? And what's the distance? It's 1. And from node 1 again to this node. Now we change our n1 to this node, so this becomes our new n1. Now from this node 1 we move to the next node, which is this node at index 2, right? And what's the distance? The total distance from the starting node to this node is equals to 1 plus this 1, which is equals to 2. So Now finally we have reached this node, and this node has no outgoing edge, so we end up there. Now we evaluated for node 1. Now let's do it for node 2. For node 2 we start from the same node, and since there is no outgoing edge, so we go nowhere, and the distance is equals to 0. So now the result should be the maximum should be minimized. Maximum of distance between node 1 and node 2 to the result should be minimized, right? So what's the distance here? Well, both starting from the starting point, this is the common node, right? And the distance here is equals to 2 when we move in this way from node 1, and from node 2 it's equals to 0. So what's the value? Maximum of 2, 0 is equals to 2, right? So this is our result distance, and the resulting node is equals to 2 as well. So now we are also going to return 2. So in this case we only have one result because there are no loops. What if we have loop? Now let's look at this example here. So our node 1 is 4 and node 2 is 0. So let's start from node 4. So let's cool. So now that we have, oh okay, so I missed index 2, 3, 4 and 5. All right, so what's the value for index 2? It's 3. So 4 is pointing to 3, and what's 3 pointing to? It's pointing to 5. So 3 is pointing to 5. What is 5 pointing to? Nothing. So now we move to node 2 with starting from 0. So what's 0 pointing to? 0 is pointing to 4, index 4. Cool. So this is what our map looks like. We do not need index 2 and index 1 because basically it doesn't make any difference here. If we want to add, let's just add it and look that it doesn't actually make any difference. So 1 is pointing to 3 and 2 is pointing to 0. 2 is pointing to 0. So now what we do is we start from node 1, which is our node value equals to 4. So we start from this node 1. So from node 1, what we are doing is we are going to create a map. It is basically an array with each index value. So now what's the map for 4? So for 4, the initial value will be 0 because that is the starting point. Similarly for this node 2, initial value will be 0 for index 0. Now from 4 we move to the next index, which is equals to 3. And what will the value for 3 be? 3 will be equals to the previous value from where we reached 3 plus 1, which will be equals to 1, 0 plus 1. And then from 3 again we move to the next node, which is equals to 5. So now 5 will be equals to 3, the value for 3 plus 1, which is equals to 2. And then finally from 5 we do not move to anywhere because it has the value -1. So since it has the value -1, we stop right there. And then we move to the next iteration for node 2, starting from 0, index 0. So the value is equals to 0. From 0 we move to 4. So the value for 4 will be equals to 1 because it's at distance 1. Then we move to 3, which will have the value equals to 1 plus 2 because it is as distance 1 plus 1, which is equals to 2. Right, this one plus this one, which is equals to 2. And then from 3 we move to 5, which is equals to 3. Now we have our map. Now what we do is we start comparing starting from index 0. So at index 0 we have the value for map 2 at index 0, but we do not have the value for map 1 at index 1, so we skipped this one, and then what we do is we look for index 1. We do not have it any for index 1, so now we look for index 2. We do not have that as well, so now for index 3. So index 3, map 2 has value 2 and map 1 has a value 1. So the minimum distance between the maximum of these two is equals to 2, right? So it's the max is 2 and the node is equals to 3. So far we have found this answer. Now let's keep moving. So the next value we find is 4, and what's the minimum, like what's the distance, max distance? It's 0 and 1. The max is 1, right? And the node value is equals to 4. So between these two, what's the minimum? Well, of course this is minimum, so this is our result now. And then next what we do is we move to the next index, which is index 5. And for index 5 we have the value 2 and 3, and the maximum of this is 3, and we know that 3 is greater than 1, so we just do not compute our result. So finally we return our answer at node 4. So that is our final answer. And if you look at this graph, if you just look at this graph here, then you would know that 4 is the answer by just looking at it, because we are starting at node 0 and at node 4, and the minimum distance is when we take one step from 0 and no step from this at all, then we reach node 4. So that is why this is our answer. So that was for our for this example. Now in case of examples where we have loop, we also need to check if we have already visited that node. If we have already visited that node, because we are using BFS search, so we are not going to revisit that node, because in breadth first search we know that if we have already visited the node, which means that the minimum distance has already been found, so we do not need to make a change. So now let's start coding. So what do we actually need? We need the maps, map 1 and map 2, and we need to store our result and our node, but initially we only need map 1 and map 2. So we need to create our maps. Let n is equals to ages.length. Let map 1 is equals to new array of length n, and fill all the values by -1. Let map 2 is equals to new array of length n, filling all the values with -1. And let's just assign the value for our node 1 equals to 0, because that is our starting point, right? So we want the distance from that point to that point itself will be equals to 0. Now that we have assigned the values, let's create our while loop. So for node 1, what do we need to do is we keep on evaluating as long as we do not fall into the loop. That is the map value. If the map value is equals to -1, then we keep on moving, because else we just stop there. We do not evaluate that one, because now that we know we have reached loop, so map value should be equals to -1, and we have not reached the end of our loop. That is, if we reached our end, that is, there is no next node. So if the next node is not equals to -1, and if there is no loop, that is map 1 is not equals to -1, that is when we update the value for our map 1 should be equals to, from where we came, plus 1. So the value of node 1 plus 1, and then we are going to update our node 1, which will be equals to age is node 1. So this becomes our node 1, and we are going to do the similar thing for node 2. Alright, now that we have created our map function, now let's iterate through each of the values in the map array. So let's define our result. So y minus 1, because if we cannot find any possible answer, then we return a -1. So that's why I have assigned it the value -1 if there is no such result. Now what we do is, if we check if map 1 of I, if that age has never been reached, then we are not going to evaluate. Else what we do is we check let value is equals to the maximum of map 1 of I and map 2 of I, and then if our result is greater than the value, then we update our result. So our result will be is equals to value, and then we also update our node to that node, and then finally we are going to return our node value. Now let's run our code. Should be equals to, because if it is not equals to, then we have already reached that node, and that would lead us to a loop. Let's submit our code now. Great. So the time complexity for this solution is O of n, because we only have one for loop, and this while loop which only executes worst case would be O of n, and the space complexity is also big O of n.